Hello students, welcome back to my channel. In this video we are going to discuss about dielectric in an external electric field. Okay, so in the previous video we discussed about what is dielectric and polarization and susceptibility. All these we discussed. Now we will study what is the behavior of a dielectric when an external electric field is applied. So we already studied about the behavior of conductor. In the case of conductor, what will be happen? So an external electric field is applied. So I am going to consider as a conductor. In this conductor, what is that? There is an external electric field is to be applied. Is in this direction. So an external electric field is in this direction. So in the case of conductor having charge carriers. So due to the external electric field, the positive charges are shifted to this end and the negative charges are shifted to another end. Due to this, there is a electric field will be generated inside. Okay. So how these shifting, or we can say that redistribution of the electric charges will be happen up to which E external will be equal to E inside. So you can see that this to be in the opposite direction. So we can say that net electric field inside will be 0. Okay, the net electric field inside a conductor is to be 0. Okay, that is about the case of conductor. Now we will see what will be happen in the case of dielectric. Okay, so we already studied in the case of polar or non-polar dielectric, the external electric field is applied. There is a formation of net dipole moment. Okay, so how it will be happen, you can see that. The external electric field. Okay, this is the external electric field. So you can see here. So this is to be a dielectric slab. In this, due to this external electric field, the negative charges are to be in one end. All the negative charges are to be in one end. It is to be reoriented. These dielectric molecules atom does not have a capacity to move. So due to stretching or reorientation, there is an internally electric field is to be generated. You can see like this. So you see that there is a dipole moment. That means positive and negative to be separated. So the dipole moment is in this direction. Clear? This is the dipole moment in this. Okay. So when an external electric field is to be applied due to stretching and reorientation of this molecule to produce a net dipole moment inside the slab. Okay. So you see it here. You can see it here. Other than the ends, in between all the region, you see this, all this area. What about here? So here the positive and negative centers are coincide. Here positive and negative coincide. Positive and negative coincide. Positive and negative. Here also positive and negative coincide. Positive and negative is to be coincide. That means what we can say it here. The net charge is only present over this surface and net charge is present only over this surface. Okay. How this is to be generated? These charges are to be generated due to the external electric field. Okay. So we will be say that there is a sigma, negative sigma here. What is negative sigma mean? Surface charge. Negative charges. You have to imagine as a slab in the three dimension you have to imagine. Okay, so you can see like this. Clear? Okay, so the same case, this is generated due to the polarization, so we will say that minus sigma p, and this is also plus sigma p. Okay, this side all will be positive. That is about the here. So due to this will be produced as a electric field is in which direction? You can see that the electric field is in this direction. Okay, internal electric field. Here the external electric field is in this direction, E external. Okay, but in the case of this, the internally generated electric field is not to be equal. So what about, there is a net electric field is to be present here. The net electric field is not to be 0. Clear? So there is a net electric field is present inside this dipole. So you can see that for the case of a slab, dielectric slab, what about the electric field? What about the electric field? This slab we can be changes like this. How we can change? I am going to be drawn like this. Okay, so we have to be draw in a 3 dimension. So I am to be taking like this. Here also we can be take like this. This is the case. So here all will be the negative charges. Negative charges. So here we can see that minus sigma p. Here all will be positive. That is plus sigma. Okay, so you see here what will be happen in these regions are there. Okay, in these regions are there. What about this? Here all the net charges will be 0. Only these two surfaces are there. Okay, only these surface and this surface have surface charges. Okay, what is this? Dielectric slab. Okay, so you see here, so this surface have a negative charge and this surface have a positive charge. So what we can say that? So there is, what is the electric field is to be produced by these two surfaces. This electric field, this surface will be act like a, this we can to be say that, this surface we can be say that like a plain sheet having polarized charge. This is also a plain sheet having positive surface charge. Okay, this way the dielectric slab will be up when there is an external electric field is to be applied. Okay, there is an external electric field is to be there. Here also there is an external electric field is there. Okay, this is the behavior of the dielectric when the external electric field is to be applied. So you can see that not equal to 0. Clear? That's it.
Thank you for watching the video. Please subscribe my channel. If you like this video, please put like